All right, case in point. Imagine that you're inside an elevator, and the elevator starts to go down, right? As it starts to accelerate, do you feel heavier, lighter, or about the same? Okay, so if you guys want to just put something in the chat, that's fine. I'll give you points for it. So you're inside the elevator starts to go down. As soon as it starts to move in the downward direction, do you feel heavier, lighter, about the same? And Reagan said lighter. Most of you guys are motion sensitive, and so lighter, 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 except Khan said heavier. All right. Those of you guys who are motion sensitive, when the elevator starts to move in the downward direction, you know you will feel lighter. And I like what Mario said. Mario, I'm going to give you 10 points because you said something a little bit more than what I was hoping for. And what you're saying is correct. Lighter at the beginning, Mario says, and then the same. That's absolutely correct. So initially you feel lighter and then the same. Beautiful. Now, when you're feeling lighter, is this just the feeling that you get, or is this really what happens if you're standing on a scale? All right, let's take a look. Now, this is our project done by a Chicago student. This was done in a high-rise building. He's got the scale. He's inside an elevator. I'm not wearing shoes. I'm not sure why, but he's not naked, or else something else would be sticking out as well. So what happens is when the elevator it starts to move down, right? It starts to move down. And as it's moving down, as it's accelerating, notice that all of a sudden, boom, you feel lighter because according to the scale, you become lighter. All right, no more, no more toe comments. All right, okay, toes are out of the picture. Okay, but and then like what Mario said, when it starts to move lighter in the beginning, that's actually true, and then the same afterwards, because now you're not accelerating. Now you're moving at constant speed. When you're moving at constant speed, it's the same, and then the elevator come to a stop, right? So it's going to start to slow down. So you know the answer. When the elevator is slowing down, do you feel lighter, heavier, about the same? And you know the answer. The answer is you will feel heavier, right? So you will feel heavier. So according to the scale, as it's coming down, it's slowing down. Boom! All of a sudden, his weight jumps up to 300 pounds. All right. So now we can draw 3 conclusions: no acceleration, no change in weight. When the acceleration is downward, you will feel lighter. When the acceleration is up, you will feel heavier. That's it. All right. So no acceleration, no change in weight. Downward acceleration, you will feel like you will weigh less. Upward acceleration, you will weigh more. All right, let's do a review of what we covered so far. All right, so what's weight? The force of gravity acting on a mass, right? Notice that the acceleration is 10. So your weight is going to be 10 times your give and take. It's going to be 10 times your mass, basically. All right, so that's the force of measured gravity, force of gravity. The amount of gravity acting on a mass is your weight. So what's mass then? Measured inertia, right? Measure of inertia. Measure of your tendency to retain your initial motion. What's a normal force? Normal force is a reaction force acting on a surface. All right, so any force that you apply on a surface is going to have a reaction force. If it's your weight, it becomes apparent weight. All right, it's a push. The normal force is a reaction force generated by a push. Apparent weight is a normal force reading from a scale. All right, so your apparent weight could be different from your actual weight depending upon what you do on top of a scale. Obviously, you can shift your weight onto a different surface, a countertop, the floor, whatever, so it's going to change your apparent weight. Your apparent weight is also sensitive to the acceleration of your body. So you're inside an elevator, and it moves from rest in the downward direction. So it's accelerating in the downward direction. So do you feel heavier, lighter, or about the same? You will feel lighter. So the question is why? We'll investigate. If the elevator starts to move in the upward direction, you will feel heavier. So the question is why? If it's moving at a constant speed, you will feel the same. So the question is why? All right. Let's come up with a mathematical model for this one. Here's the elevator. This is your center of mass, center of balance inside the elevator. Gravity is acting on you, so you got weight. All right, I'm going to place the scale right there. Scale is going to give you a scale rating, N. All right, so that's your apparent weight. Elevator can accelerate up or down, or no acceleration, meaning that it's either not moving or moving at a constant speed. All right, so, and the normal force, the apparent weight, is going to be sensitive to this acceleration. So look at the net force on the y direction. All right. Net force is what causes acceleration. Acceleration is up or down. That's what we got. All right. In this case, N is what we're looking for, but N means the apparent weight in this case because we're looking at the scale reading. All right. So M minus W. Isolate M from here. So add W's to both sides. And that's it. Okay. So we came up with that final expression for this one. So what does it mean? Which means that your apparent weight, the normal force, is going to be sensitive to your acceleration of your mass. If the acceleration is up, you will weigh more. If it's down, you will weigh less. In fact, there are 3 things that can happen. All right, let's cover all 3. Number 1, if the acceleration is up, this is your weight, and this is the reading from a scale. Your acceleration times your mass. Your mass's acceleration is going to get added to your weight, so you will appear to weigh more. If the acceleration of the elevator is down, all right, your acceleration is going to get subtracted from your acceleration. is going to get subtracted. Damn, I can't say it right. Acceleration of your mass is going to get subtracted from your weight, so you're going to appear to weigh less. If there's no acceleration, your apparent weight is going to be the same as your actual weight. All right, so what if the reading that you get from a scale is how much you really weigh? That's what it means. All right, so what I'm going to do, I'm going to turn this into a mini mind twister. All right, so what I'm going to do, I'm going to put you in an elevator. I'm going to cut the cable. You're going to be standing on a scale. Gravity is the only force going to be acting on you. So my question is, as soon as the cable snaps, if you were to look down, what kind of reading would you get from a scale? All right, so what's the scale rating as soon as you look down? That's what I'm interested in. What do you guys think? All right, I'm going to give you 20 points for the best explanation. All right, so you find yourself in a falling elevator, right? All right, as soon as the cable snaps. All right, so as soon as the cable snaps, you look down, what's the scale reading? How much do you weigh according to the scale? What do you guys think? How much do you weigh according to the scale as soon as the cable snaps? All right, Rosanna said, okay, so most of you guys are saying lighter. Okay, very good. That's not bad. Okay, that's a good start. I mean, if you had to guess, if you had to put a number in terms of a reading that you would get from a scale, what would you say? Okay, Mario says he thinks that it might be 0 because everything will be free falling. Okay, bunch of question marks. Okay. All right, so far so good. I'm gonna give everybody 5 points, and then let me just go over it, and then if somebody's right, I'll give you additional 20 points. Okay, based upon what you guys said. I'm looking for an exact answer here. Like, just give me a number on it. And all right, I think you weighed the same. Okay, so every single person for commenting, I'm giving you guys 5 points. If somebody got it right, you will get 20 points. Got it? Cool. All right, let's evaluate this. So cable snaps. You're inside the elevator. This is your center of mass. Gravity is acting on you, so immediately you will start to accelerate. Now, I want you to notice that your acceleration is in the downward direction at this point. So acceleration is going to be in the negative direction. All right, so that's the formula that we will get to use. And then, you know, this acceleration is going to be caused by gravity, right? All right, so which means that this A is the same as G. All right, so this mass is going to be the same. W is the same as mg, right? So mg, so this is the acceleration due to gravity. So what happens, your weight minus mass times g, your acceleration, mg minus mg is going to be 0. That's what it means. So, which means that the scale rating is going to be 0. Remember, scale rating is a reaction force to your weight. So which means that you're not applying any weight on the scale. Yeah, you're standing up, but your center of mass is falling at the same rate as the gravity, same as the elevator. Yeah, so your center of mass is going to remain where it is. You're standing on top of a scale, but you're not applying any force on the scale. And you feel no pressure under your feet. You're going to be feeling weightless. Mario, give yourself 20 points. Mario got it. It's free fall. You will feel weightless. You appear weightless. You will feel weightless. All right? That's it. You will feel weightless. All right, so in free fall, you're inside an elevator. You do not go up to the ceiling, and you do not fall any faster than the elevator. You will become suspended. You will become suspended. You will become suspended relative to your center of mass. So that's what happens. Okay. Okay, so the funny thing is, it looked like we did a lot of physics, but a lot of what we did, we made observations regarding, we looked at the scale, we noticed that you're going down, you feel lighter, you go up, you feel heavier. We came up with a mathematical model that agreed with the observations. But the physics is kind of like capturing the essence of this. The question is, why would you feel lighter or heavier? Where's that? Where does that come from? I mean, seriously, the elevator starts to go down, and what happens? This guy feels lighter, right? According to the scale, this guy becomes lighter. So the question is, why? I mean, there's got to be an explanation for it. Now, that question really gets to the heart of physics, because it's not something that you could capture just using math. Now you kind of have to try to make sense of, hey, thank you. Hey. So now you got to figure out, is that something that we can answer just using physics? Okay, now physics is kind of a little bit deceptive, because a lot of the times we're not going to be able to answer the why question in physics. It's more like philosophy. Very rarely you can answer that question. Instead, what we do, we make an observation, come up with a mathematical model, and hope that math is going to make some predictions that we can test. Okay, you can't really dive into a deeper question that you can answer directly, but this happens to be one of those that you should be able to. When the elevator starts to accelerate in the downward direction, you will feel lighter, and there's a good reason for it. The reason is related to the concept of inertia, guys. Remember, you're inside a car, and then the car accelerates forward. Your body moves backward. Why? Because of inertia. Your body resists change of motion, right? It wants to maintain its initial motion. Car accelerates forward, the body is going to move backwards. You put the brakes down, the car is slowing down, the body is going to move forward because of inertia. In a weird sort of way, the same thing happens here. All right. When the elevator starts to go down, the bigger your mass is, the larger the resistance to change in motion becomes. And you will see a deficit on the scale. And you see a deficit on the scale in terms of your weight because your body's going to resist change in motion. All right. While everything follows at the same rate, there's still going to be a tremendous amount of resistance. All right. So the body is going to offer resistance to change in motion. So it's either going to appear as a deficit, or you will appear to weigh less. If the elevator is moving at constant speed, obviously inertia tends to retain that motion, so you're not going to see any deficit. And also, when the elevator comes to stop, instead of a deficit, this time you will see an increase because this thing is moving at its constant speed. And then you put the brakes on, the mass is going to want to keep on moving. All right, so there's going to be a resistance to change and decrease of motion, and that's going to appear as the increase value on the scale. Okay, I see a lot of A's. I think I saw 1B. All right, not bad. Okay, if you got it wrong, you got it wrong. Not because you didn't understand, you don't understand the concept. I think it's the terminology thing. All right, I think you guys are getting better at this. Ascending means it's going up, right? But it's accelerating. We know that because it's meters per second squared. And this is the actual weight of this person is 170 pounds. So when the acceleration is up, you will feel heavier. So A is the best indicator. Most of you guys got that. All right. I'm going to give you guys 10 points if you get this one right. Okay, Mario, I know that's what you thought. Okay, this is really good. I'm impressed. You guys really got this. I'll give yourselves 10 points. All right, this is really good. So that's correct. So the actual weight of this person is 600 newtons, right? So the elevator is, when it's going up and slowing down, you will feel lighter. Absolutely, you will feel lighter. Okay, so that's one way of doing it, the life experience. The other one is when it's going up and slowing down, the acceleration points in the opposite direction of motion. So when the acceleration is down, you will feel lighter. Okay, so you guys nailed this. This was good. All right, I think this is, okay, cool. All right, so let's finish this up. This is the last portion of the conceptual. All right, so that when the elevator starts to move from rest in the downward direction, you will feel, okay, you will feel lighter because of inertia. When it starts to move from rest in the upward direction, you will feel heavier because of inertia. When the elevator is moving at constant speed, no change in weight because of inertia. Okay, lastly, when the elevator starts to move down, all right, so it's moving, slow down. Okay, when the elevator is moving in the downward direction and slowing down, you will feel heavier because of inertia, right? Elevator is going down, is it slowing down? Is it slowing down? You will feel heavier because of inertia. Okay, cool, that's it. All right, so we're done with this one. Okay, so let me